Hello students, today we are going to discuss the next chapter, that is matrix, adjoint of a matrix. And the main objective of this chapter is to deal with the solutions of linear equations. At the end, our main objective is to find this linear equation, solutions of linear equation by matrix method. Very important for board point of view. But before that, we will do some of the problems to find the adjoint and inverse of a even square matrix. See, few of the important topic in this chapter is, the first one is, what is a singular matrix? Singular matrix. See, a matrix is said to be singular if the det value of that matrix is 0. If the det value of that matrix is a 0, then you can say the given matrix is singular matrix. And non-singular matrix. Non-singular matrix are those matrix whose det value is not equals to 0. Now you know how to find the determinant value of a given matrix. So easily you can check these two things, whether it is equal to 0 or it is non-equal to 0. After that, how to find the adjoint of a matrix. Adjoint of a matrix. Again, for adjoint of a matrix, I told you the method is simple. Find all the cofactors of the element. Suppose I am considering a 3 cos 3 matrix, that is a third order matrix. So write down all the respective cofactors of the elements: C11, C12, C13, C21, C22, C23, likewise like this. And then at the end do the transpose of the matrix. You will get the adjoint of the given matrix and inverse of a matrix. Whether you can find the inverse of a given matrix or not. So for finding the inverse of a given matrix, see, what is inverse? Inverse is represented by this symbol, inverse of a matrix. See, very easy. Conceptually, we can say, if A into B, suppose if you find the multiplication of two matrix, and again do the commutative property, if we are applying B into A into B, and after that B into A. If we are getting an identity matrix of the same order, I am writing here n, because if you are considering this 2 cross 2 matrix, second order matrix, then it will be I2. If you are considering this third order matrix, then it will be I3. So if A into B is equals to B into A, that too the value is an identity matrix, you can say B is nothing but inverse of A. B is nothing but it is the inverse of A. Just like what we say, identity matrix represent a unit matrix that represents 1. That is, if you want to find a number such that if you multiply both the numbers, you will get the result 1. What you will do? 2 by 3. So this is the same way. A into B equals to B into A. And then what you will get? You will get a unit number. So like this you can remember, B is nothing but inverse of A. That is, this number is nothing but, instead of 3 by 2, the reciprocal of 3 by 2 is 2 by 3. So this is the reciprocal of this number. Now few of the property which very important property, that is, if you multiply A into B, two matrices, and if you are finding the inverse at the end, after multiplying A into B, what you will get? You will get again a new matrix. If you then, after getting that matrix, if you find the inverse of that matrix, it must be equals to B inverse, A inverse. So these are the properties. You should remember these properties. You can apply these properties. Proving is not required. Right now, I am dealing with the questions only. That is which is there in the exercise. Doubts I will clear in the class afterwards. Okay. So very important property, A into B whole inverse is equals to B inverse into A inverse. Now, how to find the inverse? See, the way to find the inverse of a matrix is A inverse. A inverse, you can find the inverse of matrix, that is adjoint of A divided by mod of A. Mod of A means that value of that given matrix. You know how to find adjoint, and you also know how to find the mod value or the det value of the given matrix. So one more question is there in this topic, that is existence of an existence of a matrix, whether it is invertible or not. Invertible means whether you can find the inverse of a matrix or not. So existence inverse of a matrix only exists when det of A is a non-zero number, non-zero matrix. Because if it is a zero matrix, then it will be undefined. If this is a number, det of A is a number that is zero, so anything divided by zero is undefined. So the important condition for the existence of a matrix, whether it is invertible or not, is that it must be a non-zero number. Now you can do few of the problems from the exercise. The next one. One matrix is given to you. 1, 2, minus 3, 3, 1, minus 2, minus 2, 0, 4. Find the adjoint of the matrix. Here you have to find the adjoint of the given matrix. How to find the adjoint of a given matrix? The method is to finding the adjoint of a given matrix is just write down all the cofactors. See the way cofactor of 1 1, that is the element which is there in the first row and in the first column. First row and first column, that is 1. So the cofactor of this element is what? Just eliminate these two things. What you will get? You will get a second order determinant, 1 minus 2 0 4. So like this. See, I am showing you the best way how to find the adjoint. Better you draw 9 determinants of second order and just fill it up. How? For 1, what you will write? 1 minus 2 0 4. So 1 minus 2 0 4. For 2, what you will do? 3 minus 2 minus 2 4. 3 minus 2 minus 2 4. For minus 3, it will be 3 1 minus 2 0. For 3, 2 minus 3 0 4. For 1, just eliminate the row and column. What you will get? 1 minus 3 minus 2 4. For minus 2, 1 2 minus 2 0. For minus 2, 2 minus 3 1 minus 2. For 0, 1 minus 3 minus 2 4. And last one, 4 1 2 3 1. So this is what I have written. I have written all the minors of the elements. Now the sign convention, as I told you, plus minus, this will be minus, again plus, then minus, plus, again minus, plus, minus, plus, and do the transpose. This is the way to find the adjoint of a given matrix. Now easily you can find all the that value of this. So I am doing the calculation. See, I have finished the calculation. One mistake is there in this element 0 C32. So I have rectified it, and the result you got is this. I paused the videos because the memory will increase. It is very difficult to upload this video. Now, second one again. I am taking the question from the exercise itself. Find the inverse of each of the following matrices. Again, one matrix is the second order. What you have to do? You have to find the inverse of this matrix. So for inverse, what you want, adjoint of A and then det of A. Det of A is very easy to find. 5, 1, minus 3, 4. So 5, 4, 20 and minus 1, minus plus 3. So this will be 23. And how to find adjoint? Again, for adjoint, get cofactor of all the elements and then do the transpose. So cofactor of the element 1, 1, that is 5. Just eliminate the row and column and write down the element. Again eliminate this. Again 1, and for 4, first row, second column, second row, you will get 5. Now the sign convention, plus minus. While doing minus, this will become plus. Again minus plus transpose. Do the transpose 4, 3, minus 1, 5. So this is the adjoint of A. At the end you can write, therefore A inverse is 4, 3, minus 1, 5 divided by 23. This is the answer. Simple. Now see the next question. Second one. One matrix is given to you, a second order matrix. A matrix A is 1 tan x minus tan x 1. What you have to do? Show that A transpose dot A inverse is equals to this. So for transpose, you know how to find the transpose of matrix. Just interchange the row into column or column into row. So first row, convert this first row in first row. So 1 tan x, 1 tan x. Second row, second column, minus tan x 1. One part is over. Now for A inverse. For A inverse, again you know how to do A inverse. Adjoint of A by mod of A. Now adjoint. For adjoint, C11, C12, C21, C22, then do the transpose. So for first element, just leave the first row, first column. What you will get? 1. Write down 1. For second element, first row, second column, you are getting minus 10x. For this element, you are getting 10x. And for last one, you are getting 1. Now the sign convention, plus minus. So minus, this will become plus. Again, minus, plus. Transpose. At the end, do the transpose again. So 1, first row, interchange first row into first column. 1 tan x, then minus tan x. 1. Now you have to find mod of A. Mod of A is 1 tan x minus tan x 1. So 1 into 1 is 1, minus a formula, and minus tan x into tan x is minus 10 square x. Again minus or minus plus, 1 plus 10 square x is sec square x. So A inverse is 1 by, because 1 by det of A, that is 1 by sec square, into adjoint of A. Adjoint of A is 1 minus tan x 1. Now again, what you have to prove? You have to prove transpose of A into A inverse. Therefore, transpose of A into A inverse. What is transpose? Transpose of A is 1 minus tan x 1. And A inverse is 1 sec square x 1 minus tan x 1. See, you can take this value here because it is not there within the matrix. You can consider value here. Now do the multiplication of this. So it is the multiplication is feasible because second order, both the matrices are second order. So first row into first column. So 1 into 1 is 1, and minus tan x into tan x is minus tan square x. Again, first row into second column. So 1 into minus tan x is minus tan x, and 1 into minus tan x is minus tan x. Now second row, first column. Tan x into 1 is tan x, and 1 into tan x is plus tan x. Tan x into minus tan x is minus tan square x. 1 into 1 is plus 1. See, 1 by 6 square x. See, you can write tan square to be sin square by cos square. Sin square by cos square. Then do the LCM. You will get cos square minus sin square x by cos square x. Here it is minus 2 tan x. So you can write minus 2 sin x by cos x. For this 2 tan x, that is 2 sin x by cos x. And 1 minus tan square x, again cos square x minus sin square x by cos square x. Because tan square x is sin square x by cos square x. Do the LCM. Cos square x minus sin square x divided by cos square x. Now see, if you will take this 1 by 6 square, you can write 1 by 6 square to be cos square x. So if you introduce any number, or you can take common cos square x, anything you can do. Better you introduce this number within the matrix. So you have to multiply this number with all the elements. So 1 by 6 square is cos square. While multiplying this, cos square cancel. And you know cos square x minus sin square x is, the formula is, it is there in class 11, cos 2x. Again cos square x divided by cos x, cos cancel. But one cos, there will be one cos remaining. So minus 2 sin x into cos x is minus sin 2x. Again multiply this, you will get sin 2x. Again cos square, 1 by 6 square, cos square cancel. Again you can write cos 2x. See, you will get the result. You will get the required result. And this is the result. Okay. So the last one, I am considering the last question. So I am considering question number 11. So here one matrix is given to you. What you have to do? Find A inverse. And also show that A inverse is something A square minus 3i, that is third order identity matrix, divided by 2. So let us find first A inverse. For A inverse, we have to find two things: adjoint of A and det of A. So det of A, so consider this first row expanding along row 1. So first element is 0. So no need to consider this because this is already 0. And then the result will be 0. Then also I am writing 0 into 0 is 0, minus 1. So plus, then minus sign. So minus 1. Again leaving this row and column. 1 into 0 is 0. Minus 1 into 1 is minus 1. Plus, minus, plus. Again plus 1. Leave this row and column. You will get 1 into 1 is 1. 1 into 0 is 0. So 0, minus, plus 1. And again plus 1. That is 2. Now the second thing, adjoint. So how to find adjoint of this matrix? You know what you have to do. Make 9 determinants of second order. Give a transpose sign. So first write all the minors of each element. See 0. 0, leaving this row and column, you will get 0, 1, 1, 0. 0, 1, 1, 0. 0 1 1 0. For second element, leave this row and column 1 1 1 0 1 1 1 0. For third one, 1 0 1 1 1 0 1 1. For this element, 1 1 1 0 1 1 1 0. For this element, 0 0 1 1 0. For this, 0 1 1 1 0 1 1. For this element, 1 1 0 1. This element, 0 1. And last one, 0 1 1 0. Now do the sign convention: plus minus plus minus plus minus plus minus plus. 0 into 0 is 0, and minus 1 into 1 is minus 1. 0 minus 1 minus 1 minus plus 1 0 0 minus 1 0 minus 1 0 minus 1 minus 1 minus again plus 1 0 minus 1 plus 1 0 minus 1 transpose. And do the transpose. Minus 1 1 1. First row, change this first row to first column. Second row, 1 minus 1 1 1 1 minus 1. So here I can say the inverse is what? Mod of A is 2, that is 1 by 2, and adjoint is minus 1 1 1 1 minus 1 1 1 1 minus 1. So this is our first part, inverse. Now second part, to check a square minus 3a by 2. So for a square, now what you have to do, you have to find a square. A square is nothing but a into a. You can write a square is nothing but a into a. So the only thing you have to do is to multiply the matrix A to A. See, and you know how the multiplication: first row first column, then first row second column, first row third column, after that second row first column, likewise. So 0 into 0 is 0, 1 into 1 plus 1, 1 into 1 plus 1. Then first row second column, 0 into 1 is 0, 1 into 0 is 0 plus 1. Last, 0 plus 1 0. Now the second row first column, 1 into 0 is 0, 0 plus 1, 1 0 1. And the third one, 1 0 0. Row 2 column 1, 1 into 0 is 0, 1 0 1 0 0 1 1 0. Now see, 2 1 1 1 2 1 1 1 2. The next thing you have to do, a square minus 3i. A square is 2 1 1 1 2 1 1 1 2, and 3i. I means identity matrix. Identity matrix. Now both the orders are same, so you can subtract the matrix. So introduce 3 to the here, it will be 3 3 3 diagonally. All the elements will be 3. So 2 minus 3 minus 1, and rest of the element is the same because 0 1 1 1 1 and minus 3. So 2 minus 3 minus 1, again 2 minus 3 minus 1. So one more thing is there, you have to check a square minus 3 by 2, that is half minus 1 1 1 1 minus 1 1 1 1 minus 1. So at the end you are getting the result to be half into this matrix, and the value of A inverse is what? Half minus 1 1 1 minus 1 1 1 1 1. Yes, I have checked the result. Both were same. Both the results were same. as proof. You can say. Now you have to do the exercise of your own. Any doubts? Please WhatsApp me. I will give you the solution. Thank you, students.